Hello, everybody. Welcome to the vertical projectile motion crash course for your final Matric exams. This topic covers roughly 15 marks, and that's 10% of the paper, okay, which is significant, but it's a fairly decent section. There are just some important points that you need to consider that we're going to talk through now. Firstly, the two definitions that they can ask you, okay, is that of free fall, which we know is a motion where the only force that acts on the object is gravity. And what is a projectile? Okay, which is an object where that's given an initial velocity, but thereafter the only force that acts on it is gravity that pulls it down. Okay, those are your definitions. And there are 5 variables. What are these variables that we need to consider? There's the initial velocity of the object, the final velocity of the object when it's at the action, right? There's the acceleration of the object. And for an object that is in vertical projection, the acceleration will always be 9.8 meters per second downward. Okay, gravity will always, no matter what. So this is basically a constant that we can say, and the sign, whether it's plus or minus, will depend on what direction you take to be positive or negative. So that's quite important. Your frame of reference is important, so note that. Time, okay, how long has passed, and of course our displacement. So these are the 5 variables. The 4 equations of motion, which you know, and is in your data sheet, I'm not going to write those out, will include 4 of these variables. Any 4 of these variables, you will always be given 3 out of the 4 variables, which will allow you to solve for the last one. All right. There are some instances where you may have to do a simultaneous equation, but it's still the same principle. 3 out of 4 variables will be given, or it'll be hinted to you, or you must be able to infer it from the scenario. But the examiner can only ask you for that last 4th variable no matter what. So you will be able to use one of those equations of motions to solve your project. So make sure that you break up each stage of your motion, okay, to consider a new set of variables for each stage. We're going to talk about what that means just now. Just remember that when they use the words uniform velocity, okay, uniform, okay, velocity doesn't mean the velocity is wearing a uniform. It means that the velocity is staying the same. So VF final is equal to V initial, right? Deceleration, when an object decelerates or slows down, acceleration is negative. And we know that at rest, if an object is at rest, its velocity is 0. Got it? Cool. Now let's look at the 4 scenarios, the 5 scenarios that your examiners can ask you. There are only 5. There are only 5 scenarios that your examiners can ask you in this section. The first one is a falling object. Okay. Now I teach my students to take down as positive. Okay. Downward is positive motion, upward is negative motion. All right. So the falling object scenario, you have a ball, it comes down, lands on the ground, and your initial velocity is there, your final velocity, you write it there, your change in time, and your acceleration we know is going to be 9.8 meters per second. And it's positive because downward is positive. And here we have our displacement, our vertical displacement, which is change in y. Got it? Great. So that's your first scenario. You'll have a falling object, simple, straightforward. A second scenario is the object is thrown vertically upwards from the ground. What does that mean? So we have the ground. Some fella there is playing with the ball. He takes the ball and he throws it upwards. And then it falls back down, okay, to the ground. So there's 2 parts to this motion, which I spoke about earlier. So there's 2 stages. So if we say this is A, B, and C, A to B is 1 stage of motion. B to C is a 2nd stage of motion. How do we compute that? What does that mean for us? So it means that we'll have 2 different sets of variables. Okay, so firstly, this change in y is the same. Okay, it's a constant vertical displacement. Change in y. It's a bit too thick. And for both A, B equals, you know, A, B, C, it's the same. The acceleration we know will be the same. Acceleration for AB is going to be 9.8 meters per second. Okay? And because it's going up, your acceleration is going to be negative because we teach that downward is positive. Okay? The ball is going up, so think about gravity acting against the ball, which means it's pulling it back down, so that's negative. All right, so that's kind of the understanding there. At rest, at this peak, at the peak, right, or the turning point in the parabola, at the peak of the ball's motion, the velocity is 0, we know that. The change in time from A to B is equal to the change in time from B to C. So that stage of motion to that stage of motion, the time will be the same. Why? Because of time symmetry. We call that time symmetry. The time will be the same. So that helps us with our problem solving. All right. And yeah, your VI goes here. And this would be your VF here, which equals your negative VI. There's also symmetry in that. So the final velocity will be the negative of the initial velocity at the same point. So at any 2 points, if you had to cut through here, and this was 5 meters up, and then at the same point, 5 meters from the ground, the velocities will be the same at that point. Cool? Yeah. Now the third scenario is with an object that's thrown from a height. Okay. So say you're standing on a terrace, and then you throw a ball from this height. You throw it, so you give it an upward motion, and then it falls to the ground. Gravity takes over. So you've thrown it, you've given it energy, and that energy takes it up. And once that energy is exhausted, why does that energy get exhausted? Because gravity is acting against it. Okay, acceleration. And thereafter, gravity takes over and the ball falls to the ground. Okay, that's your ball. Will also be here. Okay, this is also important. So what do? We need to write down where our variables will be here and make sure we can account for them, which will help us solve the problem, whatever they ask of us. So your change in y happens here, which is, if we say this is point A, point B, C, well, actually, let's make this C. That's one motion. So change in displacement, vertical displacement from A to C. Okay, you can use is this. This is the displacement. Yes, the ball went up there, but it came back down. So from starting to the ending point, that's what displacement is, not distance. It's just that here. So if we said you were standing on an 80-meter high building, that's what the displacement will be. The total vertical displacement is for this motion system. Okay, your initial velocity that you threw the ball with is there. The velocity here at B, will be 0. All right, and you know that the velocity here at this point, because it's in line with A, to the same height from the ground as A from where you threw it, it's going to be the negative of VI because it's coming back down, so it's going to be the opposite direction, negative. And at the bottom here, you've got your VF goes here. Your change in time for the whole system, AC, and acceleration is going to be 9.8 meters per second. Okay, we can take it as positive for the whole system. You don't overthink that. That's fine. So some people do break up these two parts of motion if necessary, but we don't really need to do that. I don't teach that because the question, it's not really useful for the types of questions that they ask with the scenario. It's useful just to take into account the entire motion more than anything else. And just remember these things. The velocity here will equal the negative of the velocity that you threw it with. Here, velocity is 0. V final accounts for the whole motion, and your displacement accounts for the whole motion. Acceleration and time accounts for the whole motion. Let's do a fourth scenario that they can ask, which is one that I happen to like. It's quite similar to the previous one, but there's something that you have to account for. So this one is the hot air balloon problem, right? So an object is thrown from an upward ascending object, from an upward ascending point. Okay, so your balloon is moving up with a certain velocity. All right, and from it you are standing there, and for some reason you drop something, or you throw something, or not throw. Sorry, the scenario is usually you drop. Sometimes if they want to complicate it, they will say throw, but I've hardly ever seen that. So you've dropped an object. Okay, you drop a ball, that ball will increase because of inertia and whatnot, and then it will come back down to the ground. Okay. So this is the vertical displacement that you're going to take as your change in y. This is, we know it's going to be 0. Then initial velocity, right, is going to be the velocity of the balloon minus, or rather plus, actually, the velocity, because it's plus minus, so minus minus plus, the velocity that you threw the ball with, okay? So if you happen to drop the ball, so that's 0 velocity thrown, the initial velocity will just be the velocity of the balloon. But if you throw the ball at a certain velocity, then you add it to the velocity of the balloon, because that's the energy that the ball has with which it moves up. Okay, and the gravity takes over and it drops back to the ground. So we know there's change in time variable, and there's your acceleration equals 9.8 meters per second per second. Okay. Your fourth scenario, and also your final velocity here, don't forget that, just so we've accounted for all our different variables. The final scenario that they ask is a bouncing ball. Okay, so some students struggle with this, but it's again the same principle. You just need to break it up into stages. Okay, you can break anything up into stages if that helps you a bit better. So number 5, the bouncing ball. Get a ball and then bounces the ground. Reaches the maximum height, comes back down. Reaches the height there, comes back down, etc., etc. It can continue, but it will stop eventually because it loses all its energy. So you need to consider each stage of motion carefully. Okay, if the ball rebounds elastically, okay, if the ball rebounds elastically, if it's an elastic collision, then the velocity that it bounces up with immediately will be equal to the velocity just before it hits the ground. So usually will be an elastic collision. So what does that mean? That means that the VF in this from A to B is equal to the VI from B to C. Does that make sense? And then if we call this D, E, and F, the VF from C to D is equal to the VI from D to E. Okay? If there's an elastic collision, that's what that means. That helps you. And if the collision is inelastic, that means that the energy is lost when it hits the ground. Okay? And so it will leave the ground at a lower velocity, and so the maximum height will decrease. So this is an inelastic collision, right? Because its maximum height decreases because it's losing energy, quite straightforward. And acceleration will always be 9.8 meters per second downwards, okay? Just in terms of graphs, okay, this always helps. So the slope means gradient, okay? Change in y over change in x. And the area. So the graph of position versus time, okay, will give you the area of the graph of position versus time will give you velocity. A velocity versus time graph, okay. The slope of the velocity versus time graph will give you the displacement, rather change in y because it's vertical. And the area of the velocity versus time graph will give you acceleration, 9.8. An acceleration versus time graph, slope will give you velocity. And then this nothing, this won't really give you much, right? So just remember that, and you should be able to work it out and plot your graphs. Cool. Hope